Hi, DOJ.
All right. Thank you for hosting me, everybody. It's delightful to be here speaking to you about some of the most exciting topics that I know of around large language models. This series has been quite interesting from what I've caught from some of the earlier talks. It's a little bit of an advanced audience, but in here, a lot of what I do is try to simplify some of the major ideas that I find are concepts that a lot of people, either developers or people who are making decisions for companies, need to have as large language models sort of grow in adoption. And it's easy to say sort of what a time it is for AI and language AI and what these models are able to do. So I used to go, there are talks that I gave at Hugging Face and other places using a very similar slide to this, where it's like, it seems that developments in language AI and language processing are have the potential to be massive changes in human civilization as a whole, where this jump in, let's say, language technology, which was inventing writing, is literally what we call the beginning of history. And then the printing press inventing that is sort of how we're allowed to have books everywhere and sort of increase literacy. And I used to say this in talks to people, to say LLMs and large language models are exciting. I don't need to do that anymore. A lot of everybody I talk to now has now come across these models and their capabilities of creating images, of writing, and creating value. And I used to, like, the one difference I would say now is, in the past I would say, okay, maybe language models might have a 10% chance of being as big as the printing press and the invention of writing. But now, I'm upping that percentage a little bit, and I think a bunch of people sort of agree with me. So my name is Jay. I write about large language models. I've been writing about these systems for about 9 years. I have a book coming up called Hands-On Large Language Models with O'Reilly. It's due for July, but you can access 200 pages of it right now. It's an early release on the O'Reilly platform. And for the last 2.5 years, I've been working at Cohere, which is a large language model company founded by Aidan Gomez, and Ivan and Nick is his co-founders, who were very early LLM people. Aidan was one of the co-authors of the Transformers paper. And it is my fascination about this technology that sort of had me join Cohere. And from joining Cohere, being able to see how this technology goes out from the lab into business applications. I'm really interested in that trajectory of, okay, how does this cool technical idea become a feature in a product, or becomes a full product, or it launches entire new industries, which is what actually happened. So that is, let's say, Cohere's general sort of mission, is to empower developers and enterprises, and I have a hand in that through education and through sort of building with these models and understanding where they succeed and where they fail, and sort of communicating it, which is what we're doing here. So with this excitement, now is an incredible time to be building the intelligent systems of the future. Right now, the crop of the engineers and builders alive now have abilities and capabilities and tools that they can build with, that no other generation of humans have had in the past. And central to that is the idea of generative chat. That was the one thing about a year and a half ago that really sort of brought this to the public imagination. If you had to be close to NLP in the past, before, let's say, what is 2022, before, to really understand, how GPT-3 was exciting and the potential there. But things like ChatGPT were like how this got on the radars of everybody, including, let's say, the C-suites and the boards of directors of every company. And the first thing that people sort of started thinking about is generative chat. So, okay, now we have software systems that are able to communicate, and they were very big controversies, if you remember them, about is this a sentient being or not? Because we were really surprised as humans when we have software that is able to write coherently and respond and communicate. But then that leads a little bit to a misguided way to think about these systems, of thinking of them as a monolith or a mind. What I generally advocate thinking of them is a collection of tools or a collection of capabilities that you can use to build great systems and build better systems. So the goal of this entire, let's say, talk here is to say, don't think of these systems as text in, text out, black box, but think of deconstructing them into the various capabilities, and then just adding them to your toolbox of things you can build with. And if you're thinking about language models, you can break this down into two families: so language understanding capabilities, and then language generation capabilities. And then if you have models like Stable Diffusion or DALI or Sora, they still use the language understanding capability of a text language model. That is the first component of those systems. But then there are other downstream systems to generate those images. So even if you're not dealing with the text modality itself, the language understanding, as let's say the rise of language models, enabled this new method of us interacting with software through commands, through the prompt. It is a dull interface, but it's useful in a lot of use cases. It doesn't need to replace every interaction surface that we have, but it's one thing that language models now gave us. So that's on the language understanding capability. On the language generation, there are a bunch of other ways to, let's say, break it down to. But you can think of language AI or text AI systems as having a collection of capabilities, language generation being one of them. And then generative chat is only one of these. So even generation has many, many use cases. So summarization, copywriting, and then now we're seeing with the abilities of reasoning, you can start to think about things like agents and, let's say, higher and more advanced capabilities that really seem like sci-fi. And if you ask anybody 5 years ago, they would definitely feel like something that is science fiction. But then language generation is only one of a stack of things. Another one is called semantic search. So these models enable us to improve search systems through doing search by meaning, where you're not just comparing keywords, but also any system that you have, any system that you build can be a little bit more intelligent in how it classifies text. So whether this be tweets or messages or emails, a system being able to apply a label to these messages, and when we get incoming emails, do we tag them as returns or shipping or customer service or something else? That's another sort of use case that language models excel at. And I advocate for these other use cases because these, especially things like search by meaning, semantic search, or classification, are a lot more reliable as use cases than the generation, which is um, showing a lot of potential, but then you also have to be very, very careful in sort of how you build that system. And so when you think about some of the most robust and reliable systems you can build with language models or AI, they tend to be more on the understanding side now, and they, let's say, can complement the and we'll talk about the interplay between generation and understanding in a bit. So semantic search or search by meaning is one of the most reliable applications. And the basic idea there is that you have a search system. And when we talk search system, we don't necessarily mean Google search, right? Every app that you have has a search capability. And if you're going to build a website or an application of any sort, it will need to have a search functionality. So you search Yelp and Airbnb and Spotify and Shopify and all of these. And so search is a major component of anything, any say digital product out there. And the majority of search systems, or all of them before language models, were based on this idea of keyword matching, where you match the keywords in the query with the keywords in the document. But then if you have a query like this, which is Brazil to USA travel visa, if Brazil and USA were um, replaced with just the positions, and it became USA to Brazil, a keyword system might, or maybe a naive keyword search system might give you this, let's say, other result, which is a document that is not relevant, but it shares every keyword with the query. But language models enable this idea of having more semantic search that is able to match the meaning rather than the keywords. And this is a strong capability. So semantic search systems can be broken down into a few categories, but two are the most important ones, I would say, to bear in mind. One is called dense retrieval. So this is search by embeddings, and the other one is called reranking. Dense retrieval works like this. So you have a query, then you have a search system that takes that query, and that this search system can be, if you've come across vector search databases or databases, regular databases that have vector search capabilities. If you've done something with Pinecone or Weaviate or Chroma or any of these tools, this can be the system in the center here. And that is connected to a text, and then it gives you the relevant search results from this text archive to this query. And basically behind the scenes, how this works is in sending this query to an embedding model, getting back a vector, a list of numbers that capture the meaning in a certain way, and then through nearest neighbor search of the embeddings in the archive, you get the top results. So this is a basic idea that needs to be known widely beyond, let's say, developers, and that's the idea of dense retrieval, and that assumes a previous idea of having to embedded and chunked all the text that is in the text archive. On the Cohere side, embeddings is a major focus. Embed v3 is the latest sort of model that the team has shipped out. It works in 100 languages, and it's geared specifically to this major use case called retrieval augmented generation that I'm sure a lot of you have come across, but it was one of the major factors where this embedding models were sort of improved to give the best results for this. We've also released many millions of, maybe hundreds of millions of embedding vectors. So you can go to huggingface.co/cohere, and there you can download every Wikipedia chunked and embedded with this one model. We did this release last year, and then we just last month, we haven't announced this yet, but the release is out there and it is public. We have a new drop of Wikipedia embeddings with the new v3 model that you can go and download now, but it's not in 10 languages, it's in every Wikipedia language that is out there. And so that is something you can download and build with and do, let's say, inject that knowledge embedded in Wikipedia in any application that you want. But I'm also excited in things like exploration and embedding visualizations. So feel free to go there and download those and build cool things with them. And so embeddings is the idea that powers dense retrieval. It is very underrated as an idea, and let's say as in the capabilities they can give search systems. But another one is called reranking, and reranking is the fastest way to inject the intelligence of a language model into a existing search system. So a lot of companies or systems already have a search system, maybe even a keyword search system, but then with reranking, you can add just one more call, and that becomes a better system that is powered by large language models. And it works kind of like this. So you have your query, you send it to your search system. The search system has access to documents. It gives you a set of results. So your existing search system, this does not have to be an embedding search system. It can be let's say, Elastic or any kind of search system. It gives you 100 results. And then you pass these 100 results and the query to a reranker, and then it just changes the order of these 100 based on the relevance to this query. And this vastly improves search systems with only one call at the end of that search pipeline. And so now you have a search pipeline of, let's say, 2 steps or 2 stages. The basic idea of how that works is that a language model is presented with a query and with each document, and it assigns a relevance score of how relevant is this document to answer this question? And then based on these relevance scores, you just sort it based on these relevance scores, and you get the signal of relevance from this language model. And so this is how you break re-ranking down into basic classification. And this is how it works with this idea called a cross encoder, where the language model is presented with two pieces of text, the query and the result. And here you can see how it improves both embedding, let's say, lexical search or keyword search systems, but also how it can empower embedding models, and it just adds uplift to any search system that you have by adding this one step. And so these are two language models that are not generative in nature. These are language understanding models that really empower search systems, embeddings and rerank. In 2019, this is just maybe about 6 months after the BERT paper came out. So transformers is when a lot of this rage for deep learning became big. And the initial transformer paper was a major paper, but it was really addressed machine translation. And then after maybe the following year, or a few months later, the BERT paper came out, which was using transformers for a lot of different use cases, including sort of things like search. And Google Search rolled out using models like BERT for search just a few months after that paper came out. And they called it the biggest leap forward in the history of search. So this is 20 years from Google having all of the data of the world and some of the smartest search and information retrieval people. Just this one addition of a model presented the biggest leap forward in the history of search. And using a re-ranker is the best way to sort of inject that for companies or shops that can't build their own model, let's say. And you can see this with Spotify as well, who use models like this to empower podcast search. One thing that is good for people to sort of wrap their heads around as well, and this is some content from chapter 3 from the upcoming book, but it's some visual language, because as people try to build search systems, and a lot of it is just to empower RAG systems, some ideas of how to evaluate retrieval are important. And so some basic visual language to understand the building blocks of evaluating search models are kind of like this. So let's say you have a query and you have two search systems and you want to sort of compare them. Is this system better than this one? Like, that's where you need a metric to sort of help you define this. And so this is the major way. You have a query, you have the systems, and then you have the top 3 results that these systems sort of bring back. So let's say you pass the query to search system 1 and it gives you 2 relevant results. Result number 1 is relevant, and then result number 3 is relevant, but 2 is not relevant. And then you have search system number 2, which only got you 1 relevant result. Now, you can say that, okay, system 1 is better than system 2 because it got me 2 relevant results out of the 3, while system 1 got me 1 out of 3. And this is maybe one of the most basic measurements or metrics. So we can call this accuracy at 3. So a lot of search and retrieval evaluation metrics have this at, because they evaluate the results at, let's say, the top 5 results or 10 results. And this is important because a lot of times when you search Google, you only get 10 results. And so evaluating the top 10 results is much more important than the results from 100 to 1 million. And so that's the idea of this at that you will find when you find these retrieval metrics, like accuracy at 3, which is what we're looking at here. But then accuracy, while it's the easiest to understand, or say to explain to people maybe who are not engineers, there are definitely use cases like this, where the two systems both have accuracy at, let's say, at 1 here of being 1 out of 3 for this one query. But the search system 1 is clearly better here because they got the relevant result at the first ranking, but system 2 had the relevant result at the 3rd ranking. And so we need better metrics. We need to incorporate the rank of the relevant results in the score, and that's why we use, let's say, more advanced things like average precision or mean average precision. I won't go necessarily into the calculations, but this just establishes that to test search systems, companies need something like this, or people or developers need something like this. So you need to have your archives, of documents. That's what you have there on the left. Then you need to have a set of queries. And then you need a scoring or relevance judgment of which documents are relevant for each query. And once you have this test suite, you can then just throw it at these retrieval evaluation libraries that will give you a score for accuracy or relevance or precision or NDCG or others. But this, that's a basic way, is one thing that answers, let's say, one of the major questions that people have when they want to build their own search system, and they're like, okay, how do we evaluate it? How do we compare this search system versus that one? The first way that you need to do is do something like this. And something like this, in a way, can be automated with language models as well. So it's kind of a tool that's being used more and more, is for you to say, okay, if I don't have queries, I have the documents, I don't have any queries yet, you can generate queries. You can send a language model a query, a prompt like, this is a document, generate a relevant search query from it, or ask a question that can only be answered using this document. And that will give you a first, let's say, a seed of data here that you can fine tune and correct and work with later, instead of manually sort of labeling everything together in the first step. And then the score that we looked at talk about one query. What you need to do is just evaluate the query and then evaluate across queries as well. And that's how you get something like mean average precision. I won't go specifically into the details here, but these are the main ideas or concepts that are good to sort of have. And so even if you're interested specifically in generation and chat, search is definitely vital for the future of generation. And the intro here is to say, if you ask a question to a model, would the model have a better chance of answering it correctly if you actually gave it the context, if you actually gave it the answer in the prompt? And this was the first, maybe lesson that the collective public have learned after these generative chat models came, which is the idea that these models will answer questions very confidently and be wrong very confidently. And here's the label of hallucinations sort of came about. And if you were close to NLP, you would know this a little bit, that yes, these models are trained to generate text, but they don't have to be factual. That is not a part of their training. And so one of the best ways to augment this is to do this two-step generation, and it's called retrieval augmented generation. And the idea here is that this relies on information that is not stored in the model itself, in its parametric memory, so to speak. The information is actually sourced from a database or from an external source that you can update with time. And so here you can have smaller models, you can update the information, but also you can give user one access to a piece of data that user two does not have access to. And then it also gives you this slight way of, let's say, being explainable. The model can say, I'm giving you this answer based on looking at these documents. And this gives a little bit more transparency into the behavior of the model. And so retrieval augmented generation is maybe one of the main use cases that are, let's say, in adoption right now, and different teams are sort of building with. And it is the interaction of generation and search. And basically, the concept of it is kind of like this. So in a chat system, the language model doesn't just answer directly, it has access to a data source. And then that access can be defined in so many different ways. And, how many data sources that you have is also another thing that a lot of developers sort of need to problem solve for. So now we're thinking of this pipeline of breaking down the output or the generation of, or answering a question into these two steps. So we're not sending it to the LLM directly. No, we're doing a retrieval step, and then we're doing a generation step. And one schematic of doing that is to pass a query to a search system. This can be an embedding system. This can be a hybrid search system that uses both keyword and embeddings. And then that can be put in a prompt. You can put the top 1 or 3 documents into the prompt as context and then pass that to the LLM. But also you can improve that by having a re-ranker there to choose the right or to have an extra signal for which documents are more relevant to answer this question. And so here we start to see language models being used in both steps of this one flow. So we have embedding language models, we have re-ranking language models in the retrieval step, and then we have the generation model on the generation side. Now, a lot of people would take a code example of something like this and roll it out to maybe production or some use cases, and then see that users would ask a question like this. So it's good in demos that we ask a simple question like, where do the tallest penguins live? But when you roll this out and have people interacting with it, you'll have somebody who asks, we have an essay due tomorrow. We have to write about some animal. I love penguins. I could write about them, but I could also write about dolphins. Are they animals? Maybe. Let's do dolphins. Where do they live, for example? So do you take all of this and you throw it at the search system, confusing it by the mention of dolphins and about the scenario in which the user query arises is very different from what types of queries search systems are trained with or expect. And so this was one of the major ways to improve the retrieval section of these models. And one way to do that is to do something like this. So this is Cohere's Coral model. If you go to coral.cohere.com, you can interact with the model, and it does this web search prior to answering questions if you use grounding. So if you give it this entire question, it says, okay, I will search for where do dolphins live. And that idea is called query rewriting. And then here, now we're using a generation model in the retrieval step to rewrite and to find the right, let's say, query to search the retrieval system with. And so this, let's say, distills this large text into these into the simple query, and then that gives the retriever a better chance of finding the better documents that are relevant for the search. And then you can re-rank after that as well. But then when you use a re-ranker, which of the two queries do you use? And my hunch is that their advice is to actually use the initial question, because re-rankers tend to be sort of trained with question answer pairs. But it's worth evaluating on both. But these are some of the experiments that you'll need to run for your example. On the Cohere Coral side, there's this specific way that you can call, we call query mode, and that turns a query, or let's say a large text, into the actual query. So it rewrites it. So it's able to give you the search query to search for. Now, our research pipeline for RAG kind of looked like this. Now we have 3 language models in the retrieval step, in addition to the generation model, and that's how we can improve this model further. But then think about queries like this. If you have somebody that says, compare the technical specs of PlayStation 2 versus PlayStation 5. So you have 2 pieces of information. And if you do it, let's say, naively with query rewriting, do you search for this? Do you wait for a document that has actually compared the two? That is one way, and you might have success with it, but you probably will not. You will most likely need to think about this additional idea called multi-query. And this is another sort of capability here of this query rewriting engine to say, okay, to answer this question, you need these 2 queries. And these 2 queries, you go search for them, and then you, let's say, synthesize finally with the language model. And so now we have searching for one query, searching for multiple queries, But there are a lot of cases where you want to incorporate searching for no queries. So let's say you're building this RAG assistant, and if a user says hi, do you want to throw that hi at your vector database or your search system to actually get a grounded answer? You do not. So there are cases where like you need all of these things. You need this query rewriting engine to say, I do not need a query to answer this, or I will need one query or let's say multiple queries at one time. These are some of the things that people quickly start to think about as concerns as they build their RAG systems. And from here, you can, let's say, a couple of things to touch on here is a few, let's say, more advanced ideas is to say, there are queries that you cannot answer just by querying two things at the same time, but you need to sequentially search things. So you can say, maybe, compare the current GPUs of NVIDIA and AMD. You first need to find or search, okay, what is the names of the latest, let's say, models that are out, and then maybe you search the specs. And then here you're in this domain of multi-hop retrieval or search. And here now you've stepped secretly without maybe realizing it into agent territory. And then agents are this idea of just abstracting these multi-step processes with language models into let's say a better, deeper abstraction. But also another concept involved here is that the search we're using here can be abstracted into something we call a tool, and the agents will need to interact with multiple tools, where search in a search engine or search in this database or search in Slack are different tools that the model sort of is able to. And these are the exciting abstractions that people are building with agents, as I think we've seen in the Sherpa talk just prior. And that's an exciting area for these systems. Now, after a system or a language model sort of gives you an answer, one good way is to force it to actually give citations. And that's another way that the CoChat models here sort of present the results. So it'll give you an answer. You give it a question and a set of documents. It'll give you an answer and it will say, okay, these two words are sourced from this document. And this, let's say, span of text is sourced from this document. And this gives the end user the ability and possibility to double check the work of the model, which is very important, that we don't ascribe models with trust they haven't earned yet. And we empower people with the ways to actually validate the output and empower the experts to double check the work of the model. And then we can put this all together in something like this. So I have a query, you hit the search system, that presents its results to a reranker. The reranker passes it to the LLM that gives you the citations. That's, let's say, one RAG pipeline that we can think about. We have a dedicated guide with the Colab that goes through building all of this with all of these endpoints. So this spans embeddings, reranking, query generation, as well as citations, and you can find it here. And yeah, so we definitely continue to need better tools and abstractions to build LLM pipelines. And I'm not associated with this effort at all, but I'm fascinated by it. I'm spending quite a bit of my time learning about tools like DSPy. You can check the Cohere YouTube channel for an interview I've made with Omar Khattab, the author of DSPy, sort of introducing some of the ideas. And I love that it just has a lot of powerful abstractions that allow you to build and think in building LLM pipelines and build what they call LLM programs, which is kind of a new abstraction that is important. It needs a little bit of investment to understand, but you can clearly, very quickly see that, yes, these are strong abstractions. It's better to build with tools like this than just lugging around strings of prompts here and there. So yeah, that's my just recommendation to generally just think about these various capabilities as tools that we can use to chain and build smarter systems that just go beyond this text in, text out. RAG being one of the highest sought after use cases in the industry at the moment. We have something called LLM University, so LLM.university, where we explain. I work with some of the best machine learning educators, Luis Serrano and Mior Amar, who explain a lot of the concepts involved around retrieval augmented generation, text generation, embeddings. So this is it's completely free. You can access it without signing up. To check out LLM University, check out cohere.com. Thank you so much for listening.